Okay, well now it's working. We have the collision. Hello all NES makers, this is Metsipit Games and welcome to this tutorial about big bosses. This is the last tutorial of the first series. In this tutorial we are going to make the collisions working and make the game a bit more playable. But don't worry, there will still be an advanced tutorial in the making in the future, where I will be making a playable level out of this big rat thing over here. But for now we are sticking to this version of the tutorial where we have these different enemies falling down and player needs to dodge them. Okay, maybe first we could start to look what we had before. So this is the current phase of the tutorial. Enemies are falling and fading in and out, but there is no collision. And that is exactly what we are going to do now. To make these enemies colliding, we are using actually the NES Maker's built-in collision system for objects. So let's start by making one dummy object. Let's select this, and the graphics are not very important, but pick just some graphic to show that where the collisions are on screen at first. And then we're going to object details. Pretty much leave these basic. We only check this is monster and monster weapon, and actions can be, we can check ignore gravity, and this is the most important value. We have to set the collider box for the object, and for this game we make it quite big because our enemies are big. Let's make it 32 by 32 and leave some space around it, like 10 pixels. Didn't 32 and 32. No. 32. These are hopefully saved. Let's close this. Object details. Let's check if they were saved. Yes, values are saved. Okay. So now we have this another object in our game. Something to remember is that this object is at location number 1. It will come important later on. Okay, then we have to code the collision system. So then we need to create the collision, and we are using some NES Maker code in here and going to modify it a little. Here is this macro called create object. This what this does, it makes an object in free object slot in your game. But this time we want to make sure that our object is placed always in the same spot, so it's easier to handle. So let's copy this and make a new subroutine for our project and call it update create collision. Just paste the macro. We don't need this. we should leave here these arguments there because we are going to need these values later. But here's the part where the free object slot is selected. So we don't need this. Only thing we are doing, we are forcing it to use the object spot 9. Okay. We don't need this label either. Then we can just put some basic values for these. This is the Y. It can be 0, 2. The previous one was X. And this is the object number. This is what I told about earlier. It is currently on space number 1, as seen here. This is 0 and this is number 1. So we are referencing to this object by making this value 1. And this is the object shape, actually the animation that we don't need the animation frame either. It can be 0, 2. Okay, then we can let the NES Maker do create object routine, do the work, and initialize our sprite. Only thing we need to do is to return from subroutine. And this needs also to be called from somewhere. Let's put the RTS after this one too. It needs to be called at the start when the screen loads. So we must go to our script settings and find the screen load. Extra screen load script. Go to edit and just jump to our subroutine, create collision here. So this runs in every screen. If you have have a game where you don't want this to happen on every screen, you have to make logic around this. And actually one thing we have to remember is we have to switch bank because our boss script lives in bank 1D, and return the bank also. So now it's been created. Let's see if there's already something happening. Yeah, it's happening just as it was supposed to do. The object we created is over here, and it does have a colliding box. If we jump into it, it's like 32 pixels wide, but it's located in the upper left corner, so it's not really going to be much of a help right now. So we need to add some more code. What we'll need, we need a few tables about our enemies. The first table will be the enemy collision X coordinate, and it starts now from number 1. So we can leave the first value as 0. It doesn't really matter which value you select for this, but the next value we have to check from our project. Here's our first enemy, and as you can see, the X is number 6, so we need to put that in our table. X number 60, and the next enemy X number is 10, so it is A0, and the other enemies, I have checked them before, they are as follows. And we also need some kind of offset for the camera Y coordinate, so we need another table with the Y values. These are you maybe if you make your enemies at different places, you may need to check them manually with which places these are. This is 90. This is B0 and 70. Okay, so the first one is also, you can put literally every number here, it doesn't matter. The code starts from spot number 1. This is enemy number 1. Number 2. Number 3. And number 4. Okay, now we have some locations for our enemies, and we can start making our collision routine. One thing over here I noticed when going through the code is that this animation frame can really go quite wild because it's not checked anywhere. So actually we can make this check, and this move path has 27 animation frames, so we compare it to 27, and if it's equal, if we have reached 27, so we don't increase the animation frame anymore. Okay, so now we have made these collision points, so next thing we have to do is to actually update the collision. So let's make another subroutine, update collision, and at first we have to get the collision Y coordinate, which we just made, and when calling this function we make sure that the enemy is always in Y. Okay, this is the cam offset, so of course we have to subtract the camera from that SBC cam Y. Then remember our object was made at spot 9, so we need to load that to that to X, and start manipulating the object's position. So let's store object Y I X, and let's load collision X, comma Y, and store it to object X high, comma X. Autocorrect, like this, and then we have to return from the subroutine. So all this does is takes the numbers we had input here, and subtract the cam offset, so this actually glues the object into the same position as our as our enemies. Okay, and this isn't called anywhere either. So here is the place where we are making the enemy. We first reveal it and then update it. So we need another action here in the middle. So let's do double check and check we are using the enemy number 1 here, and jump to subroutine. We just made update collision. So this is the thing I said, that we need to be sure that our enemy is in Y, as seen here. We expect the enemy to be in Y. And another phase where we need to put this update collision is actually this second phase too. So let's put it right here in the beginning. This is the phase where the enemy has already fallen down and waits for this timer to tick 50 and reset the whole process. We do want the collision to be active in that phase also. The collision starts in when the enemy is revealed and was falling down, and stays there until the enemy is hidden. Okay, I'm not sure if this is going to work, but we'll see. Okay, at least something is working. It's on the right spot, but yeah, now it's working. As you could see, it's only working for the first enemy because we didn't copy the code. But when the first enemy is falling, this small little collider falls with the enemy, and if you touch it, you die, or at least lose a life. Maybe it would be better if our player had infinite lives for now. So let's go to herd player, and we can comment this out so it doesn't warp even if the lives are 0. So now we have to copy this same logic to every first and second phase in our code. So every time there is this reveal enemy and it loads the enemy over here, we have to put this jump to update collision after it, and also remember to put it on the phase where enemy is staying down too. Okay, so I guess I just edit this one out and we'll come back later. Okay, so now we have every jumps at place, and also remember that you have to change the Y to the current enemy. This is the last enemy, it's number 4, and this is number 3, etc. So now we could have something that works for every enemy. Let's see. Yeah, it works for this enemy at least, and this one. And as you can see, our player has infinite lives, so we can hit our enemies as many times as we want. There's only just this small bug where you can see that the dummy object appears on some strange places. There's a fix we can make, so let's make that next. Okay, so let's go back to hurt player again, and then let's make a check that checks the current animation frame. And if the animation frame is smaller than 5, we don't hurt the player at all. Like this. These animation frames are being set to 0 every time in these phases, so it's easier to put everything in one place. So let's take all these out. Stored animation. We can search the animation frame. Every time we reset it to 0, we just delete the line. Okay, I guess that's what's all, and then we have to set it somewhere where it happens at the right spot. So we can go to our next random. This is the spot where the animation has ended and we can safely reset it. But we need to change the function a little. We make a jump. Instead, this just returning next. If it has been found, we can go there. Otherwise, we go to next random. So we are just looping this function if we haven't found it. But if we have found it, next random. Next found. So we reset the animation frame over here. Here is the basic that comes with NES Maker. We can just make our own here. This is actually from the forums. It's a forum post by Takuika Ninja, and this randomization routine is much faster and more efficient. It makes more random numbers than the previous routine. So at first we load the random seed. This is a variable that is already in NES Maker. Then we shift it to left and branch if it's bigger, and we make an EOR operation against 9E. I don't actually understand totally how this code works, but I found out this makes pretty much this makes more random numbers than the basic routine. We add this number and store it to random seed 1 and return from subroutine. Okay, let's see what's happening now. Okay, unknown label 356. What's that? 356. Next found. Sorry. Let's try again. Okay, now it's working a lot of better. It doesn't make any false objects over there. It only makes these for the background. Yeah, but you may notice that there's this one enemy that's pretty much that's almost as wide as the screen, but it does have this one. It does have only one collision box, so we need to make another boxes for these other enemies too in this line. In our update collision function, we need to make a special state for the enemy, which is number 2. This checks if the enemy number 2 is in Y, and if it's not, we can branch out of this. But if it is, we can use the V-blank timer again for this purpose. We make V-blank timer and make 2 separate cases for it. The first one can be like this. And I have checked all the values already, so the value for the other x is D0, and we store it to object X. And this is the first case. Then we need another case. Let's make it another byte here. And this is the leftmost enemy. Okay. Now we should have collisions for the other spikes too. You may notice that this collision doesn't work on every frame, but the frames switch so rapidly so that it's not a problem. You can see here. Oh, the collisions is working if I just jump fast enough. They are working for each one of these spiky balls, as you can see. Okay, well, basically we have the logic done for the game. There's only one thing to do. We don't want to show that dummy sprite over there, so we can hide it pretty easily. We can hide it in here. Maybe we can go and check what this actually does. The status byte for the object is located. Do handle objects with camera script. So here's the status byte. We can copy this for our information. So what we want to do, we want to tick the drawing byte of the object. So it does all the collision checks and everything. It works as an object, but it just doesn't show up and doesn't eat our precious sprite space on our screen. So at first the object, you remember it was object number 9, and every object has this object status flag. So we load it, and we have to check if the object has been created already. So we check active, not queued for activation, and pretty much every other thing than queued for the activation. So it's active and not queued for the activation. And if we have found this object, or if we have found not, we skip through it. But if there is this kind of object, we flip the 1 bit of the byte. That's this observer's drawing. So second byte, second bit. And then if we go to our game, we should see that our sprite has been vanished. Okay, not yet. Something wrong. Oh, of course, we we have to store it into object status. Yeah, object status. I was afraid that the bugrat would appear again, but I hope not this time. Okay. Well, now it's working. We have the collision, but we don't see the sprite, and also the sprite isn't drawn. It's not just a blank sprite, but it's totally not drawn, because it doesn't eat our H sprite vertical space as it did before, if you were noticing. Okay, well, this is our game. You can modify this even further if you want to make maybe some kind of score system, add lives to this game. That's all the basic NES Maker stuff. Or you can even try to make bigger enemies. You can make them like almost like full screen if you wish, and make them move through the Y-axis. The X-axis is a bit more difficult because there is so much code in NES Maker already that checks the X movement, but I think maybe we can tackle it and make some kind of working big rat boss in the advanced tutorials. But this is the tutorial for now. I hope you have enjoyed watching these and maybe learned something new, and we'll see next time. Maybe there would be a slightly longer pause between the next video, because there is a lot of things I have to check before making the big rat boss actually working. But as always, have fun making NES games, and goodbye.